Thank you, Olivia. Welcome, everyone. This webinar is going to be focused on our new cnWave 60 GHz products and how LINKPlanner can help you to get an idea of basic network performance with them. During this webinar, we will lay out a simple PMP network, add some PTP links, and look at the channel planning capability for the 60 gig parameters. We'll have a section for question and answers at the end, but feel free to add your questions to the chat box as we go along, and I'll try and keep tabs on them as we go. We're going to start by designing a cnWave 60 GHz PMP network, which, if you're familiar with designing PMP networks in LINKPlanner for any of our other products, follows a very similar simple process. We will start by adding the network sites and subscriber sites, and then set up an equipment template before adding the hub sites. This will also give us the access points or distribution nodes as they're known in the 60 GHz world. We have an additional step in the process to adjust the orientation of the DNs, as each DN covers 280 degrees, unlike the normal 90 or 120 degree antennas we use for our other PMP products. This means that we can't add several at a site to form a composite 360 degree coverage, so we need to be a bit more careful with their orientation. We will then finish by connecting the subscribers or client nodes. So let's see how all this works in LINKPlanner. We can start a new project simply by clicking the icon at the top. As you can see, I've already done that bit. If you have a list of all your site locations, just make sure that the network layer sites where your distribution nodes are located is in a separate file from your client node site details. These are imported into LINKPlanner from the File menu under Import. And then we'll pick network sites from CSV. The format of the CSV file for the network sites and the subscriber sites is the same and contains the name, latitude and longitude, maximum height and description. The height and description columns are optional. If your file format is not quite the same, then you can simply align the titles with each column. If you wish to not use a particular column, then simply select Ignore. And the description column you can use multiple times if you wish. So just follow the instructions through and the sites will be added to LINKPlanner. Then we will follow the same process to add the subscriber sites. So we've now quickly been able to create both the network sites and subscriber sites into LINKPlanner. Next, we will create a PMP equipment template to define the distribution node equipment using the access points section in LINKPlanner and the default subscriber equipment we want to use. The PMP equipment template is found in the navigation menu under Project Configuration. Select New Template. It's getting there. And then just simply give it a name. If you're familiar with the other PMP products in LINKPlanner, the first part of the access point equipment template looks very similar to the menu options when we define the access point equipment. And then below it, we can see the subscriber product options that can be used with this AP equipment. We configure the equipment starting in the top left and working left to right and top to bottom. So we will start by setting the band to 60 GHz. And this then changes the options and layout to the parameters required for the 60 GHz DN. At the moment, we only have one DN product, the V1000, which consists of two sectors, and the equipment configuration section is duplicated for both sectors. Configure the parameters on each sector. Some parameters, like the modulation mode, are common to both sectors. There are a couple of new parameters specific to cnWave 60 GHz. The CN capacity limit allows throughput to be reserved for the mesh backhaul DN links. By default, it is set to 100%, which will allow all the throughput of the sector to be used by the connected CNs. To reserve capacity on a sector for any DN to DN connections, reduce the CN capacity limit. The max CN registrations allowed is similar to the max registrations allowed parameter on other products, but with cnWave, we also have to think about any DN to DN connections on the sector. Each sector can support a maximum of 15 connections. So if a sector also has a DN to DN connection, then the max CN registrations allowed needs to be reduced. So we'll just take this down to 14 on both sectors. As for the other products, these values can also be reduced to maintain higher throughput rates to the CNs. The DM power is controlled by EIRP, which also includes the antenna gain. The EIRP is also common to both sectors and is configured on sector 1. It will automatically show the maximum EIRP allowed by the product and the regulatory limit for the country. To reduce the EIRP, tick the user limit box and then set the EIRP required. We'll leave it at full power for this example. So now we'll move on to look at the client node required in the subscriber module equipment. So we can select which client mode we want, and you could select a maximum modulation mode. There is some information that's deliberately not included in the templates, such as antenna height, as this can be different for each site and we wouldn't want to override it if applying a template across a network. Configure the equipment settings as required and any performance parameters you want to apply to the whole network. For example, if you need to achieve a certain data rate, you can configure the minimum modulation mode that is needed for that data rate. If you have any optional extras that you also want to be added to every DN and CN, then these can be added in the template. By select New Extra, then you can select the item that you want by ticking the box and selecting OK. Now we've configured the template, we'll shut that down. And next we will create the hub sites and access points. Select the new hub menu and we'll see that all the network sites that are not yet configured to be a hub site will be automatically selected in the left-hand box. If you don't want a network site to be a hub site, then you can deselect any that are not required. When you have a template defined, it will be automatically default to the equipment template. So we can see here the V5000 template we've just created. If you change the number of access points, then it will also automatically change the separation angle between them. For cnWave 60 GHz, we typically only want to have one DN on each hub site. And when I change this to 1, we can see that the separation angle has been updated. For 60 GHz, we also need to substantially reduce the SM range, and I'm going to use 0.2 kilometers. We can now select OK and then go back to the map view, and we can see that all the sectors have now been created. However, we can see that they're not all facing in good directions to cover the subscribers. So we need to spin some of these sites around. This is pretty simple to do in either of the map views. If you select the site and then choose the center handle on the outside of the sector, you can drag the sector around to the direction required. Be aware that this can change the range as well, but we can sort this out later. Take this one round to 140 degrees. I want this one to go to 210. See if we take this one round to just 300, we can just get the subscribers in on both sides of it. If you already know what angles you want the access points to be, you can also set them in the table view. And we can use this to set the remaining site, so I can just edit that, set that to 65. And we can tidy up these ranges back to 200 by selecting all the ones we want to change, clicking in there and setting it to 0.2. So we now have our network with all our DNs facing and covering the subscribers we want. So the final step to get us to a basic network is then to attach the subscribers to the access points. To do this, we will use the best server analysis feature. This is also found under project configuration. We can set up some guidelines for these connections. For example, we can set the target modulation mode, and we can set up a fade margin to ensure that we get a reasonable availability. The modulation mode is only considered on the downlink. On the uplink, it only checks that it can achieve at least the lowest modulation mode. We then have three options on how to configure the subscriber height. When we imported the subscriber site list, one of the columns was the maximum height at the site. If you want to use this height, then choose Use Subscriber Site at Maximum Height. Alternatively, we can select Use Height Above Ground to set the same height for all subscribers. This has the disadvantage that if this height is below the local clutter height, then the path will be obstructed and is likely to show us not being able to connect. To get around this, we can use the final option, which will use the height above the clutter, but will also use the height above ground as the lowest height, so this acts as a limiting option. In this case, we will set the minimum height above clutter to 1 meter and the minimum height above ground to 5 meters. Finally, we need to select some subscriber radios. The option list depends on the network equipment. You can select more than one option, and it will test in descending order through the list. This means that if you want to use both the V1000 and V3000, we need to make sure that the lower antenna gain of the V1000 is tested first, so that it only goes on to test the higher gain V3000 if the link can't support the V1000. You can change the order of the list by simply selecting and using the arrow keys. When all the parameters have been configured, then select Go. LINKPlanner will then automatically request all the profiles required from our servers and analyze the different possible options. If you have a very large network, this may take some time, and it will go through it in batches, updating the results summary on the top right as it goes. When it is testing each subscriber site, it is checking which access points are in range based on their sector coverage, and then ranking up to 3 possible options based on the strongest signal level. You can keep track of the runtime in the bottom left-hand corner. And we can see that this is now still going through the testing phase. I don't see any questions yet, but just remember that if you want to ask any questions, then please feel free to put them in the chat box. Hopefully this is just running through the last few tests. And now it's completed the testing and we get the full set of results in a table below. From the summary side, we can see that in this case, all of the subscribers can be connected. If we had any listed in the out of range box, then you would need to look at the orientation and SM range on the DNs to make sure that they are covering all the subscribers. If you have subscribers that are not meeting requirements, this could mean that the access points are not high enough, the subscriber option is not high enough, or the performance requirements are too tight. We can create all these PMP links by simply clicking on Create. If you have some that did not connect in the first run, then you can also then adjust the parameters. For example, the install height. Then make sure that you have emit connected places ticked, and when you hit go, it will rerun the analysis just on the places not yet connected. And you can build up the network using the strictest criteria for the majority of sites, and then relaxing them for just those that need it. If we go back to the map view now, we can see that we have a populated network. If any of your links are red, this may mean that the requirements in your template are tighter than those that were used in the best server analysis. So now let's take a closer look at one of the access points. So we can see that we have a table view here for each of the subscribers connected to this DN. So there's another parameter that may be of use to you when doing cnWave, which is called about the sector. So if you don't have that visible at the moment, then we can search and add this column. So we just search for sector. We select it, hit the right arrow to move it across the left-hand side, and then we can use the arrow keys on here to put it in the position we want in the table. And now this is going to tell us which of the two sectors each of the subscribers are connected to on the DN. In the performance summary table, we also have a slightly different view from our other products, as we default to an aggregate performance showing all the CNs connected to the DN and the total CN traffic. But you can also click on the Sector 1 or Sector 2 tabs to show the performance for each sector individually. There is a potential impact on performance if you have client nodes close to the boundary between the two sectors and both sectors are on the same channel. LINKPlanner will show a warning below the performance summary if you have this case. If you can't adjust the boundary, you may need to use a different channel on each sector. You also need to be aware that if you set the two sectors on the DN onto different polarities, then the throughput for each sector will be halved, as each sector will only be able to transmit in alternate time slots. So now we have completed our basic PMP design. In this section, we'll now look at how to plan a cnWave 60 GHz PTP link. If you want to show the mesh connectivity between DNs in a LINKPlanner, then you need to add those links as PTP links. So we go back to the layer. So using this network that we've just created, we can add the DN to DN connections as PTP links. We will start by creating a PTP equipment template, which is also found under project configuration. You select new template. This will mean that each PTP link we create will have the basic information. Let's give this one a name. And again, the same as before, we start from the top left, set this up to 60 GHz. And as we're looking for DN to DN links, having both the local and remote product as V5000 is what we want. However, we do support other interconnections between a V5000 and a V3000 or 1000, or between V1000 to 1000 or V3000 to 3000. At this stage, we will leave the goal and polarity as auto, as we will not want all links to have the same values. and we will look at planning the GOLE codes and polarity later. If you have minimum throughput requirements for the PTP link, you can add these in the performance section and also add optional extras to the BOM. So now we have our template created, we can go back to the map. And let's just connect up the sites. For our DN connections here, I'm just going to sort of make up a few squares. And now we have a PTP layer. So in the PTP links view in the navigation pane, we've now got all of those links. If we take a closer look at one of them, we have the standard equipment information at the top. And now looking at the profile, we can see that the resolution of the clutter data may be too coarse for such a short link. But on a freely available global tool, there's a limit to what we can offer in terms of the resolution. But we have added a new capability to help you manually adjust the profiles if required. If you double click on the profile, we have added an option to add more points quickly to the profile for any profiles less than 300 meters. This doesn't increase the resolution of the source data, but makes it easier for you to make adjustments to add roads, etc. into the profile. We select this interval icon, then we can choose the resolution that we would like to use. This automatically increments the points, and it will always keep the original data points from the profile as well within the new points. The terrain height is interpolated between the known points. You can now select blocks and quickly change the clutter type or add additional obstruction heights. If you have, for example, the DN or CN on the edge of the building next to a road, then you may want to make sure that the clutter classification just in front of the building is set to something low, like 0, the rural classification here. And perhaps maybe the next block of buildings is not quite so high, so we can change those and add a bit of obstruction on top of that. Go back to that. So now we can see that we can do that. You can continue to build in key features as you require, with the important areas being those close to each end and around the high points in the middle of the link. Where there is already a lot of clearance, you don't need to spend time making it accurate unless there are some higher obstructions that haven't been captured. You can use either Maps or Google Earth to help you decide on what features should be added. If we now move on to the configuration at each end, we do have the capability to set a particular channel. And although it says transmit frequency, you can also see the channel numbers when you come to choose the frequency, so you don't have to remember the exact frequency for each channel. In the product, the GOLE code must be the same at both ends of the link. So in LINKPlanner, when you set the GOLE code, it will mirror the code on both ends of the link. The polarity controls when each end of the link transmits and receives, so these need to be opposite for each end of the link. And again, LINKPlanner will keep that under control for you. The performance summary and performance details are very much the same as for our other products. And again, we then finish up with the bill of materials section at the end. So now we have our PTP links. So in this last section, we will now move on to channel planning for the cnWave 60 GHz network. This is very different to our other products, as it involves not just the frequency channel, but also the GOLE code and polarity. It is found in the same place as the normal channel plans under Project Configuration Channel Plans. But now we have two tabs at the top, and we need to set the cnWave channel planning one for 60 GHz. This shows the map with the cnWave sectors, but it excludes all the channel client locations to make it easier to view. The PTP links are also shown to aid planning for the DN-to-DN connections. If you build a project using the default settings as we have just done, all the options will be set to auto, and the channel plan will only have the one option in the legend in the top right-hand corner. If you have a lot of overlap on the sectors, as we can see here, then for the time you're doing the planning, it may be helpful to reduce the SM range. You can use the bulk edit feature in the PMP links access points table to do this. We just select all the sites. Drop that range down. Don't forget to put this back when you've finished, otherwise some of your subscribers may not be connected anymore. This is now just going to recalculate the network. So now we go back to the channel plan view. To configure the channel plan, you can choose the set channel, set GoLay code, or set polarity options, and then one of the options below each menu. This will then activate that choice and it will be allocated to each sector selected. We'll start by configuring the polarity. Ideally, we want both sectors on the same DN to be using the same polarity in order not to reduce the capacity. Where we have a mesh connection between the DNs, the two connected DNs have to be on opposite polarities. So this gives us a set of rules to start the configuration. We're going to select set polarity and choose the even option to start with. The active choice is shown to the right of the icons in the menu bar. Notice that the cursor has also changed to a target icon. Select each sector that you want to have even polarity. As the sectors are all currently on auto, as soon as you set one sector on a DN to even, it will automatically change the adjacent sector on the DN as well. When you change a sector to even, the sector will have a shaded color from the center of the sector outwards. Remembering what we discussed for PTP links, where the polarity at each end of the DN to DN connection has to be opposite, we need to think about where the DN to DN connections are, and hence the PTP links are useful here, and ensure that we don't set adjacent sectors with a common PTP link to the same polarity. So if we started with even in the top left-hand corner here, we need to make sure that one goes to odd, so this one can become even. That one need to be odd, this one becomes even. So now we can repeat the same exercise by filling in the odd options. When we set a sector to odd, we can now see that the shading goes from the outside of the sector, reducing towards the center. The legend in the top right-hand corner changes to include the new configurations, and polarity is shown as the last of the parameters in the list. When adding the GoLay codes, the two sectors on the same DN should use a different GoLay code, but sectors with a common PTP link should use the same GoLay code. The GoLay codes are displayed using different color schemes. So if we start by setting up the first ones on using GoLay code 1, so we set up this sector, we know that the other end of the PTP link here needs to be on the same sector. And now we have to code 2. That's on there. That one's on there. But we can also see that we have a connection here as well. That one needs to be 2 and a connection here. This one into 3. We can set those two on the outside edge there to 3 to match that one. And let's go back and put these two at the bottom here down to 1. So now again, the legend is updated to show the different options we've done, and we've got the different color schemes now for the different GOLO codes. Although many network layers will use a single frequency channel, if you are using different frequency channels, for example, to help with limiting interference between subscribers on the DN sector boundary, then sectors with a common PTP link must be on the same channel. We'll just change a couple of these to give you an idea. As we saw earlier, we have a number of clients close to the boundary on this top left side, so we could change the channel on these sectors. So we put these up onto channel 3. And again, common PTP link, so they both need to go to the same channel. We can see that there might possibly be a potential interference issue between this sector and this one. But if we also look at the way the PTP links are connected, if we were to change the frequency on any of these individual sectors, on either of these sectors, we'd have to change it on both because they have a common PTP interconnecting network. So in this case, we might want to consider something a little bit more radical in terms of the orientation of this St. Philip's sector to perhaps see whether we could move this link across into this sector, which would then free us up to be able to have these on 2 different channels. We can see as well that the legend has now expanded again to use the different channels colors, and so that's the first parameter for the channels. If you don't like the color scheme we've chosen, you can change it. To choose your own color for a configuration, click on the color symbol in the legend, choose the color that you want to use, and then you can click OK. We also have a display control on the left-hand side where you can untick options to hide them in the display. Only selecting limited combinations enables just the sectors matching that configuration to be displayed, making it easier to see any overlap issues. So for example, if we only want to see what's happening with GOLO code 1, we can remove the others, and this will highlight those. On a simple network like this, it's maybe not too much of an issue, but if you have a large, more complicated network, reducing this down can be very useful. If you're not interested in your PTP links, you can also switch those off. So this completes our section on cnWave 60 GHz planning in LINKPlanner. Just as a quick reminder, we do have a LINKPlanner section in both the forum and the knowledge base, and we've recently added articles to the knowledge base about this cnWave 60 GHz PMP planning and the channel planning that we've just been talking about. So you can find more information and review it in there as well. When we put out a new LINKPlanner release, we post an expanded version of the release notes to our forum with more background on the changes. So these are also well worth looking out for. There are many ways to get in touch with Cambium and keep up to date with what is going on. Here's a selection of the ways to find us. Coming up next week, Jagdish is hosting a webinar on elastic scalability and advanced network management with CN Maestro X. Don't forget to register for that one. We always welcome feedback on LINKPlanner, and if you have a general question or comment, then please do use the LINKPlanner section of the forum. If you have a question that you don't want to ask in public or a project file that needs to be shared, then please do get in touch with us on this email address, which is also on the opening page in LINKPlanner. Although we don't monitor it 24/7, we have reasonable coverage across the time zones and will always answer. So it's usually a faster way to get a response than raising a support ticket. Okay, so now we're moving on to questions and answers. First question coming up is about what's the recommendation having a separation difference of 2 kilometers? is it really important to have different ways? We have a default, I don't know whether this is referring to the default SM range of 2 kilometers, in which case that's just a default for a lot of PMP networks. It's not hard and fast for any particular network. It really depends on the capacity of your network and the density of your subscribers to work out what you need to have. So I don't think 2 kilometers is a guaranteed figure for any particular thing. It really is dependent on the number of subscribers you have. We have some networks running much larger than that, and some need to go much smaller because they've got a lot of customer sites in the area. And Jeff's asking about whether the information is transferred into the DN on deployment. At the moment, we don't have an automatic way for that to be transferred, but LINKPlanner, if we just go back into LINKPlanner a second, at various levels within LINKPlanner, you can create installation reports. And these are up here. And so these include all the information. Get it onto the right screen. So all the information here is then available for the installation and the commissioning notes. So this takes you through everything that the installer needs to commission on the radios. And we can get the same available at the access point or on a PTP link. Jose is looking for help making courses in Spanish. I'm not sure I can help you, but I can put you in touch with somebody I know who's going to be working on making courses in our different languages for our EMEA region. So if you'd like to drop me an email on the LINKPlanner email, then I'll put the two of you in touch with each other.